Hey guys, this is Akhil. That's Nadir. He's filming right now. And today we'll be doing a kinetics problem, and this is an exercise 4 of the kinetics notes. And before we get started, we'll just go over a little bit of some background information. So a rate law is an expression which shows how the rate depends on the concentration of the reactants. And in this case, this is N2O5. And we also have to determine the value of K. And in this case, K is the slope. And there's two types of things. There's two types of reactions that happen with kinetics. There's a first order reaction, and there's a second order reaction. For a first order reaction, it will be ln of N2O5 versus time will produce a straight line. For a second order reaction, 1 divided by the concentration of N2O5 versus time will produce a straight line. And Nadir will show you how to do these calculations.
Okay, so we're going to input our data values by adding a new document and adding a lists and spreadsheets page. And we're going to make two columns. First one is going to be our concentration. I'm just going to call that con. Second one is going to be time. Okay, so once you've entered your data, we're going to graph by adding a data and statistics page. And so the first thing we're going to graph is a concentration versus time graph to check whether it's zero order or not, first of all. Because if it's zero order, then straight away our concentration versus time would be linear. And so our x-axis will be time because that is our dependent variable, and concentration is our independent variable. And as you can see, it's a curved graph, meaning we have to manipulate the function in order to see whether it is a first order or second order. And so the way we do this is, if we go back to our list and spreadsheet page, like Akhil said, in a first order reaction, ln of concentration, or natural log of concentration, versus time will be linear. So we'll make a new column titled ln con. And what we're going to do is, in this second box right here underneath the title, we're going to input the function natural log, and we're going to put in natural log of con. And just press enter. And that'll automatically fill up all your data points. And so if we go back, now we're going to change this variable from con to ln con. And as you can see, natural log concentration versus time is linear. So we don't need to proceed any further because we now know that this reaction is first order. So the first question, determine the rate law and the value of K. So what we're going to have to do is we're going to have to find the equation of this line. And the way you do that is go menu, analyze, regression, show linear. You're going to show a linear regression. Okay. Number 1, determine the rate law and the value of K. So our rate law, like we said before, the order is first order. So our rate law will be rate equals K times concentration of N2O5 to the first power. That first power correlates to the first order. If it was second order, we would put an exponent of 2 right there. So that's our rate law. So determining the value of K. So going back to that regression equation we solved for earlier, our regression equation was ln con, so the natural log of concentration, is equal to negative 2.3026 minus 0.0069313 times time. Okay, so basically our K value is just going to be the negative of the slope. So in this case, the slope will be this 0.0069313 value. Since it's a negative, our K is negative of that negative, so it's K is going to equal positive 0.0069313. And so for sig figs, so for the remainder of this problem, to determine the sig figs, we're going to look back at the data. And looking at the concentration values, those are the ones with decimals, and that's what are going to dictate the number of sig figs. And looking at here, we see that among the concentration values, the lowest number of sig figs is 3. So we're just going to stick with 3 sig figs. So rounding to sig figs, we're going to say that K equals 6.93 times 10 to the negative 3. And our units for this case, since it is first order, is just going to be seconds to the negative 1. So reciprocal seconds. And that's how you number 1.
So the second part of the problem asks us to find the concentration of N2O5 at 600 seconds. And usually what you do for these type of problems is you want an equation in the form of y is equal to mx plus b. And Nadir already showed us the work for this. The equation is ln of the concentration of N2O5 is equal to negative 2.3026 minus the slope times time. And we use a natural log of the concentration because this is a first order equation. And usually in a first order equation, the graph looks something like this. There's time on the bottom, which is represented by x, and there's ln of the concentration, N2O5, on top. And that's represented by y. And time in this case is represented by x. So 600, we would just have to plug in into this equation. And Nadir will do the calculations for that.
Like Akhil said, we're just going to plug in the time into the equation. So if we add a new page, we add a calculator page, our equation was natural log of concentration equals negative 2.3026 minus 0.0069313. So, and then we're just going to plug in our time, which was 600, right here. And that'll get us this value. But that's not our final value yet, because the y value we just solved for is actually natural log of concentration. So to solve for concentration, we have to undo the natural log by raising e to that power. So we just do e to negative 6.46, and that'll be our answer, 0.00156. So in essence, what we did, natural log of concentration, set it equal to negative 2.3026 minus our k, and we just plugged in 600, and we got natural log of concentration equal to negative 6.46, 138, and concentration will equal e to the negative 6.46138, which is going to equal 0.00156 molar, 3 sig figs, and that's going to be the concentration of N2O5 after 600 seconds.
So the last part of the problem wants us to find the time in seconds when the concentration of N2O5 is 0.0015 m. So as Nadir was saying earlier, the equation we did get was ln of the concentration is equal to negative 0.00693x minus 2.3026. So in the previous problem we were solving for concentration, but in this problem we are solving for time. So in this case we are given the molarity, so we plug it into the y value, and Nadir will show you how to do that.
Okay, so we are trying to solve for this x value, we're trying to solve for this x value when this concentration value is equal to 0.0015 molar. So we set up our equation, natural log of 0.0015. We set up our equation. We set natural log of the concentration of 0.00150 equal to negative 0.00693 times time, which we're trying to solve for, minus 2.3026. So if we go back to our calculator, we can just recopy our previous equation, and we are now trying to solve for time, so times x, and we're going to use the function nsolve. And so we'll do nsolve natural log So we're going to nsolve natural log of 0.00150 and set that equal to our regression equation. And for nsolve, you have to put comma, the variable you're solving for, in this case x, and enter, and we get our value. So, solving this equation, we get time equals, with 3 sig figs, 606 seconds.
We just finished the 3 parts of the problem, and we'll just do a quick review of everything we learned. Okay, so to determine a rate law, like we said earlier, we have to see if the reaction is 0 order, first order, or second order. If it's 0 order, the equation will be in a y is equal to mx plus b form. As we said earlier, in a first order equation, it will be natural log of the concentration versus time. So the equation will be ln of y is equal to mx plus b. And in a second order equation, it will be 1 divided by the concentration versus time. So the equation will be 1 divided by y is equal to mx plus b. And also k is equal to the slope. And to calculate slope, we usually do two things. We can either use a calculator, like Nadir said earlier. We can create a linear regression equation. And you can review the calculator section of this video to see how you do that. Or you can do a simple y2 minus y1 divided by x2 minus x1 by picking two random points on a line to calculate the slope. And sometimes the question asks you to solve for a specific time given a concentration or a specific concentration given a time. And in our problem, we had a first order equation. So for example, our equation is ln y is equal to mx plus b. If we're given the time, then we have to solve for y. If we're given the concentration, then we have to solve for x. And that is pretty much it for the kinetics video. And yeah, that's